I'm reading Vector Search with OpenAI Embeddings. Lucene is all you need. It's a paper out of University of Waterloo that was just published on arXiv on August 29th of 2023. Now, this is a information retrieval problem. They are fundamentally trying to solve the task of you have many, many documents in your data store, and you have a query that you have just received. How do I know which of the documents in my data store are relevant to my query? They are arguing that you can just use OpenAI Embeddings with a traditional data store, Lucene. Lucene being Apache Lucene, just a indexing and search engine. You don't need any fancy vector store like Pinecone, Weaviate, anything of that sort. And beyond talking about the evaluation, they also show the engineering effort basically that's required to make this happen. They are evaluating on the MS Marco dataset, which is quite a large dataset. And they talk about how they spend 2 days making OpenAI API requests due to rate limiting, and how it's about 100 gigabytes to store all of the embeddings for the MS Marco passage dataset. So getting into the details, what they're doing is taking the documents, turning them into passages. This is part of the MS Marco setup. There are both document level embedding or document level tags and passage level tags, and they embed every passage in the dataset. Then they are embedding the queries, and if we go down to their little figure, they adopt a bi-encoder strategy. So you use the same encoder to take the documents, turn them into your embeddings, and you take a incoming query, turn that into an embedding. Do a top K retrieval, basically a cosine similarity between these two large vectors, and get a ranked list out. Now, they take a slightly different approach, and this is where Lucene is all you need comes in. They're using the indexing engine of Lucene instead of just a straight cosine similarity because of efficiency, but it's approximately the same thing. They're using a hierarchical navigable small world network instead of that cosine similarity metric. Now, everything in the paper basically boils down to this one chart that we see here. And what we get out of this is at the bottom they report their own results. That using OpenAI's ADA2, they are getting comparable results on the MS Marco dev set and the DL19 and 20 datasets. These are comparable to the other learned representations. So things like Colbert from 2 years ago was state of the art. It was amazing at doing this task. You got Uncoil and Splayed. These are models that are trained for the specific information retrieval task that ADA is matching, though not beating, in information retrieval, just with a HNSW like comparison. So you can see across each column, ADA's within spitting distance. It's not the best on, I don't know if there's any one that it's the best on, but it's within 100th or 500ths of the score for each of these other ones. Now this is passage level retrieval, and they mentioned that they are truncating everything to 500 characters, 512 characters. I would actually imagine that this gets even better the longer that the sequence is because of the OpenAI models being prepared for that. But the takeaway from this paper is you don't need all the complicated training to use your information store effectively. You can take an off-the-shelf model, an off-the-shelf database, and plug them together and end up with something comparable to the state-of-the-art research from just earlier this year even. So that is Lucene is all you need, vector search with OpenAI embeddings.